Okay, this video is 14b, and what it is a continuation of sine and cosine. In this one, the objectives are we're going to focus on what are the different variables that change the graph. And the ones we're going to cover are amplitude, we're going to talk about the period, we're going to talk about phase shift, and we're going to talk about vertical displacement. So those four things. And they're all completely independent from one another, but they all can happen to any one of the graphs, sine and cosine, and at the same time. So we're going to go through a series of slides here showing different graphics of what each one is and how it functions independently first. All right, so on all these slides, I'm going to show both the sine and the cosine graph. So notice the sine from before. We start at 0, we rotate up, back down, and then back. When we get to 2 pi, we're back at 0. Cosine, again, we start at 1, rotate down to 0, -1, 0, and back at 1 again when we hit 2 pi. So we call this a period, okay? And basically it's one cycle. And then notice it's repeated. I used a different color here, but notice the yellow curve here is the same as the blue curve, and it goes on and on and on. Okay, so our standard graph for just the function y equals sine of x or cosine of x is you start at 0 and you rotate 2 pi and you end up where you start again. Okay. Now, what we're going to look at here next is this is called amplitude. Now notice, where we see amplitude in the equation, it's the letter or the number, the coefficient in front of the function. So, if this was a 2 value, then you're basically taking the sine value and doubling everything, okay? So it's similar to the unit circle. Instead of having a radius of 1, and now has a radius of 2. So what happens is this curve actually gets twice as tall if this was a 2. So the amplitude is the vertical dimension from the middle line up to the top of the curve, or from the middle line down to the bottom of the curve, okay? So if I had an equation of, let's say, 2 sine of x, what would change is this curve would have the same period, but it would basically go up twice as tall and go down twice as deep, okay? So this value right here, I'll do it in a different color, would go up to, 2. And you would say it has the amplitude of positive and -2, okay? Really, you just say positive 2 because you almost look at it as absolute value, okay? Same thing for cosine. You're just basically getting taller, and deeper. So this is just, if we're talking about sound waves here, this is the same thing as volume, okay? Um, so if something's louder, it's taller. If something's quieter, it's shallower, okay? Okay, so let's take a look here at the next one. Now this one, we're talking about a coefficient in front of the angle, okay? And I like to refer to this as like the speed, because the speed's a good way for us to understand indirect relationship. So if this value was, for instance, doubled, so you would have what's sine of 2x, that means you're going through the circle, the unit circle, twice as fast, okay? Which means that you can go one rotation um, in half the time. Okay, so how do we get our period? Well, you basically take 2 pi and divide by b. So if our typical, so I'm going to use the example of 2x. If we start with 2 pi as your standard period, and you divide by the b value of 2, and notice the 2's cancel, and that means we can go through one period in pi. So if this point right here is 2 pi in a typical graph, well, now we could do the same rotation and get through it in pi. So we're basically going to take this curve and squish it to half the size in basically half the time. So it's going to go up, down, and up, and finish at pi instead of 2 pi. So we basically took the curve and we condensed it to half the size. Notice 1/2 is an indirect relationship with 2, and the reciprocals one another. Okay, and we see the same thing for cosine. So the period is affected by the b value. Okay, let's take a look at the next one. Next one is vertical displacement. Now this one's a pretty easy one to find, because all we're looking for is the number that's by itself. Okay, now sometimes you'll see equations, you're going to see in a little bit here on an internet site or in a book or in other references. Sometimes they take this value and they put it in the front that's okay to do. What you're looking for is the value by itself. Now think about it. If this value was not even here, and let's say I just crossed it out, you would have your basic sine of x curve, okay? But when you add d value, instead of the middle being at the x-axis, we basically shifted the whole curve up whatever d is. So if we do plus 2 at the end, that means we took the whole curve and we shifted it vertically plus 2. So let's think about it. If we had, what's the sine of 90 degrees? Okay, well, the sine of 90 degrees is 1. But then if you add 2 to it, you're now at 3. So this point right here would be at the point, 90 degrees, comma, 3. Or, we could say, pi over 2, I should say, comma 3. So I'll put a degree symbol there so we can see that. So that's vertical displacement. Nothing else changes. The period doesn't change. The amplitude doesn't change. Just we're shifting up and down. Okay. All right, let's take a look here at the next slide. This is called phase shift, and this is horizontal displacement. Now notice, how do we recognize this? This is the value inside the parentheses. Notice the x has a coefficient of 1, because if it didn't, that would be the b value, and we have to get rid of that. And we'll see that here in the example. So now, just like in parentheses, like with any sort of translation we've done with graphing, you do the opposite sign, okay? So it does x minus c. So if we're minusing c, that means we're shifting to the positive direction c. And what this is a starting point. Typically, we start at 0. And we would say, okay, the graph of sine of 0 is 0. And we would start here. But being that we are shifting everything by an angle, then we have a new starting point. So whatever this value is c, if this was pi over 2, that means we shift over to pi over 2, and we start right here. So we'd have pi over 2 comma 0 would be our new starting point. And then you go 2 pi over from there, and then we stop right there. Okay. So we have a horizontal shift for the value inside the parentheses. Okay. Now what I'm going to do here is I'm going to go through 2 examples, or actually let's go through the first. This is a little recap. So when we write these functions, this is how it looks. And notice we have the different values. We have our A, which is our amplitude. Okay. And that's the volume. It's going to abbreviate here. And that's, how high and low it gets. The B, that has to do with the period. Okay. And that has to do with, how long it takes to go through one cycle. The C is your horizontal displacement, and we call that phase shift. And D is the, value by itself. I'm just going to put by itself here as a reminder. And that has to do with the vertical displacement. Okay. So those are the 4 different aspects, and that's the format we're going to see. Again, sometimes you see this D value in the front, but each letter independently affects the curve. But notice all 4 can happen at the same time. So I'm going to go through 2 slides. One's going to be sine and one's going to be cosine, and I'm going to tackle 2 of them working together at a time. So let's take a look here at this. So notice here's our graph. This is sine of x minus 2, and notice the 3 in front. So first let's identify what's what. Okay, so the a in front, the 3 in front is your a value, and that's your amplitude. And notice our negative 2 is the letter by, or the number by itself. That's our vertical displacement. Okay, so that's your d value, vertical displacement. So first identify what's what. Okay. Now, how do I do this? Okay. Now, the first thing I'm going to do is I'm going to get a new bearing of where I need to start. Typically, everything starts at the x-axis here, but since everything shifted down negative 2, I'm going to go down to negative 2, and I'm going to sketch in a new horizontal line because everything is being displaced down a value of 2. So I'm looking at my scale on my y-axis here. Now my amplitude means instead of going up to 1 and down to negative 1, and we're moving a distance of 1, I'm going to move a distance of 3. So from negative 2, I'm going to go up to 3. And so what's negative 2 plus 3? I'm at 1. So that's the top of my curve. And at negative 2, I'm going to go down 3, and I'm going to be at negative 5. So I'm basically basing myself guidelines. These green lines are not part of the curve. They're just giving me boundary lines for what I'm looking for. Now notice my phase shift and my period are still the same. So I'm going to put lines here again. I start at 0 and I'm going to go all the way to 2 pi. Now what I have here is basically a box. And I'm basically going to highlight this box to show you what we're working in. So that's the box I'm working in. Now, if you recall, a sine curve, if I was just to sketch one real quick, starts at 0, goes up, back to 0, down, back to 0. And that's one cycle, one period. I'm going to mimic that inside my box with my new dimensions here. So I'm going to start at 0. I'll do this in blue. I'm going to start it at my 0. Now, again, I'm shifted down -2, so that's my new 0. I'm going to go up, and I'm going to go down to 0 again. And when I say 0, I'm at -2. I'm just doing reference to this graph. I'm going to go down and then back to where I started from. So notice the end point and the first point have to be in the same location. Okay. And basically what I did was I divided it into fourths. So I started here, here, halfway, 3/4, 4/4. So every graph can be divided almost into like 4 intervals. Okay. And I'm basically just going to sketch curve through that. Now again, what I want to expect you to do is I'm going to expect you to draw that same curve through the rest of the graph. So here we can say, okay, we're going to go up, and down here we're going to go down to -5, and then back up to 0. Let's take that last piece away to 0 there. Okay. So we want to sketch the curve all the way from the left side all the way to the right side so we can get a good bearing of what's going on. Okay, so notice this one had to do with amplitude and vertical displacement. I'm going to do one more graph here, and this one, notice it's a cosine. So I'm just going to sketch off to the side what a cosine graph looks like. The cosine graph starts high at +1, goes down to -1, and then back up to 1. So that's, a typical period here of the cosine graph. Okay. Now notice my amplitude is 1. My vertical displacement is none. So what we have here is a B value and a phase shift. Okay. But notice we have the 2 in front of x. And for a phase shift to work, we have to get the x by itself. So I'm going to rewrite this equation as cosine, and I'm going to factor out the 2. And if I factor it out, I basically take pi and divide by 2. And a good way to check this, all I'm doing is factoring out, is redistribute. 2 times pi divided by 2, the 2's cancel and you're back to pi. So we know I did it right. So when I look at this, my B value is 2, and my C value is pi over 2. Okay, so let's first start with this. Let's first figure out what a period. Now again, remember for a period, we take 2 pi, and we divide by the B value. They cancel, and we're going to do our period is going to be pi length long. Okay, so I'm going to put some guidelines in here again. Now first I got to find a starting point. Our starting point starts with the phase shift. Since we're minusing pi over 2, that means we're moving to the right. Okay, you do the opposite because it's inside parentheses. So instead of starting at 0, I'm going to start at pi over 2. So there's my start line. And then it's going to take us pi to go 1 rotation. Now again, what's pi? Every 2 black lines. So starting from a new starting point, I'm going to go half pi, another half pi, and 1 pi distance between those 2 lines is pi. So I'm just going to make a note right there. That's pi wide. Okay. Now again, we have no vertical displacement, no amplitude, so we have a starting point here at 0. We're going to go up to 1. We're going to go down to -1. Okay. And that is the box for a curve. So again, I'm going to highlight it. So what I'm looking at is this right here. Okay. And let's go ahead and draw in a curve. Now again, I'm going to refer to this graph up here. I'm going to start at 1, divide into fourths. So halfway through, I'm going to be down at -1, And at the end, I'm going to be back at +1. And then do my quarter and 3/4 intervals. And I'm basically going to say, okay, if that's 6 boxes wide, halfway is 3, halfway is 3, and there's my curve. Again, you don't want to draw a V through here. You want to draw a nice gradual curve that goes through the points. Okay. Now notice what I'm going to do is, I could do this in a smartboard, but I'm going to take that, I'm going to clone it, and notice I can just copy that curve over, and there's my next rotation. Okay. And let's get that a little bit lined up a little bit better. And I'm going to do the same thing this way. And notice it stops and starts in the same position. Starts here, goes down, and then pi later, and going backwards in the same spot. And it goes on and on and go. So I'm just going to slide that off the graph there so we can kind of see what's happening there. Okay, so that is how we want to graph. Now notice these are the same types of curves, but if I scroll back to this one, we had a lot bigger curve drawn out, and this one's a lot squished in, a lot smaller. So they're on the same graph, so I want you to do that so you can see the difference between these graphs, okay? Well, I'm going to stop the lesson right here. We're not going to go through any problems on the lesson. We're going to pick that up in class because there is a lot of material. But do review this, and we can go from there.